matter cannot be destroyed or created. So whatever we have on the reactant side of an equation, the left-hand side, we have to have on the right-hand side. So if we have an equation of sodium plus sulfuric acid, we will get sodium sulfate plus water. Now, as you can see straight away, we have one sodium on this side, but two on this side. You cannot change the formula. The formula, as we've looked at in the last videos, is what you create by valencies and things like that. The formula does not change. So we have one sodium on one side, two on the other. Hydrogen. We have on this side 2. We've got 2 on the other side as well. Okay. SO4s. Now, because it's one unit and it's on the same on both sides, we can keep that as one unit. Okay. So we have one SO4 on this side and we have one SO4 on this side. Now, what we need to be able to do is get a second sodium on this side. And the way we do that is add more sodium. Okay. Now, that can start to get a bit complicated. So rather than writing it out as a second lump of sodium or whatever the other elements, as we'll see in a bit as to what we're going to have, you put what's called a coefficient in front of. That tells me we've got 2 sodiums there. So now the equation balances. 2 sodiums, 2 sodiums, 2 hydrogens, 2 hydrogens, 1 sulfate, 1 sulfate. We have here the equation for calcium carbonate reacting with hydrochloric acid to give us calcium chloride, carbon dioxide gas, and that should be Ca2, not 3, carbon dioxide gas and water. Okay, you can see straight away that calcium, we have 1 on this side, 1 over here. The CO3 is not present on both sides, so we have to treat that as separate elements. Carbon, we have 1 carbon here, we have 1 carbon there. Oxygen, we have 3 on the left hand side, the reactant side. We have 2, 3 on the product side. Hydrogen, we have 2, 1 on the reactant side and 2 on the product side. And then chlorine, we have 1 on the reactant side and 2 on the product side. Now, what we need to do therefore is add more hydrochloric acid. Remember what we said? We do that by putting a coefficient in front to tell we've done that. Now when we look at the equation, we should be able to see that it balances, as we now have 2 hydrogens and we now have 2 chlorines. We have here the equation for the burning of methane gas in oxygen. And again, to balance it, if we look, carbon. On the reactant side, we have 1. On the product side, we have 1. Hydrogen. On the reactant side, we have 4. Look across here. On the product side, we only have 2. Oxygen. On the reactant side, we have 2. On the product side, we have 3. You can see, does not balance. First thing to look for is to pick, in this case, the hydrogens. How are we going to balance the hydrogens? We have 4 on one side, 2 on the other. So we're going to double the amount of water that's been made. So now we find we have 4 hydrogens there, but now we've got 2, 3, 4 oxygens. So that means we have to come back to the reactant side and look and go, how are we going to get 2 more oxygens there? Well, if we double the amount of oxygen that we're putting in, that will give us the correct equation again. Balancing equations, in this case, it's as hard as they're ever going to get. So we have magnesium hydroxide, which we're reacting with phosphoric acid, which will give us magnesium phosphate and water. You can see straight away that when we're looking at balancing this, the magnesiums, on the reactant side, the left-hand side, we have 1 magnesium. On the product side, we have 3. The oxygens, we can ignore the PO4 because that's present on both sides, but the OH gets split up. You can see we've got 2 oxygens there. We've also got 2 hydrogens plus 3 there. That gives us 5 hydrogens and 1 PO4. We come to the other side here. Oxygens, we have 1. Hydrogens, we have 2. PO4, we have 2. First thing to balance in this case will be the magnesiums. We cannot change the formula because that would change what the chemical were, but we can add more of that formula, remember. So in this case, we have 3 magnesiums on the product side. That means we need 3 magnesiums on the reactant side. We do that by adding 3 times as much magnesium hydroxide. That would mean we now have 3 magnesiums. But it also alters the amounts of oxygen and hydrogen. We can see straight away that we're going to have 2 times 3, 6 oxygens. 2 times 3, 6 hydrogens, plus 3 there, 9 hydrogens. Okay. Now we can start looking at the PO4s. We look on this side, PO4 is 2. So how we're going to get a second PO4 on the reactant side, that would be by adding more phosphoric acid. To get 2 of those, we would add twice as much. That now gives us 2 phosphoric acids. But now it also alters the amount of hydrogen again. So we've now got 6 hydrogens there. 6 hydrogens from the magnesium hydroxide. So we've got 12 hydrogens on this side. Now we come looking at the other side, at the product side. If we look, you see we've got 6 oxygens. We've only 1 on this side. How are we going to get 6 oxygens on this side? That would be, we get 6 amounts of water made. That gives us now 6 oxygens. And if we look as to what it also gives us, 2 times 6 is 12 hydrogens. Thing to remember when we're doing balancing equations, use a tally chart. Trial and error. Okay, and cannot change formula. All right, you can only add more of the same formula, we cannot change it.